Hi, Algebra Kids. Today we're going to be looking at graphs involving absolute value. To graph an equation involving absolute value, choose a table of values that includes positive and negative values. If you do not see a V shape, then you did not pick enough values to graph the equation and should choose more until you do. Note how the graph of f of x equals absolute value of x is changed in graphs 2 through 12. Let's do the odds together. So the first one is just the regular absolute value of x. Now, if you recall, absolute value is the distance a number is from 0. So if I put this into my calculator, I press math, then I choose number and choice 1 for abs, and it will create those absolute value symbols for you. Some calculators use parentheses instead, so just be careful and understand how your calculator works. So I'm going to put an X in there, and I'm going to pull up the graph just to show you what it looks like here, and you see a V. So just like a quadratic function is always a U, an absolute value function will always be a V. So now I'm going to go back to the table so I can graph those points, and I want to look for a vertex again, similar to a quadratic function. It's the turning point. So here the turning point is 0, 0, and I'm going to build on the function from there. So the absolute value of 0 is 0. So our first point is at the origin. Then the absolute value of 1 is 1, and the absolute value of negative 1 is also 1. Absolute value of 2 is 2, and the absolute value of negative 2 is also 2. Absolute value of 3 is 3, absolute value of negative 3 is positive 3, and so on. So I can now follow the pattern. It's kind of like a slope of up 1 over 1 in both directions. And I have enough to create my V. Now, of course, yours will look a lot neater than mine. Arrows on both ends because they did not give us a domain to graph it over. So that's what the absolute value of x should look like. So in this case, I have a hint on the bottom that shows us the absolute value of x, so we can use that to do our descriptions. We want the absolute value of x plus 3. So we go back to our y equals, and we're going to insert x plus 3 here instead of just x, and pull up our table. Looking for the turning point again, we see it's at negative 3, 0, so we can build from there. So we start at negative 3, 0, which is here. Then we have negative 4, 1 and negative 2, 1, negative 5, 2 and negative 1, 2, negative 6, 3 and 0, 3, and so on. So I can build my graph in both directions, using up most of the space, so it's obvious that I understand what the entire function would look like across the coordinate plane. Arrows on both ends to show that it would continue since we weren't given a domain to graph. So this looks very similar to our original absolute value function, but the only difference is if you pay attention here, so here our vertex is at 0, here our vertex is at negative 3. So this indicates that the function was shifted 3 units left. So even though it says plus, it does the opposite and goes to the left. All right, let's take a look at number 5. So for number 5, now I have 3 outside the absolute value times the absolute value of x plus 3. So I'm going to go back into my y equals and change the function. I can press second insert and put a 3 here. And then I don't have to rewrite the whole thing. And then go to my graph or my table, looking for the vertex. I again have negative 3, 0. But then negative 4 is at positive 3, as is negative 2. Negative 5 is at positive 6, as is negative 1. 0 and negative 6 are at 9. And 1 and negative 7 are at 12. And you should see a up 3 and over 1 pattern. So we can continue that. And that makes sense because that number outside that 3 kind of acts like the slope. So it looks like this. All right, and now we got to talk about what happened here. So in this case, it was shifted again, 3 to the left. And stretched by a factor of 3. And this terminology should be similar to what we saw when we were doing quadratic functions the same way. All right, let's take a look at another one. Number 7, now we have 2 times the absolute value of x minus 4. So we can go back in, change this to 2. Again, to get the absolute value function, we go to math, over to number, and choose choice 1. And we want to insert x minus 4 here. Then we could graph it just to see what it looks like. So you have a visual. And you can go back to the table to see it there. Look for your vertex, which is at 4, 0. So we go right 4 and stay at 0 as our first point. And then we build around that. So 3 and 2, and 5 and 2, 2 and 4, and 6 and 4, 1 and 6, and 7 and 6, 0 and 8, and 8 and 8. I can continue on this side and I see the pattern of up to and over 1, which makes sense because the number outside the absolute value is 2, so that acts like the slope. Arrows on both ends because we didn't give a domain to graph it over. So in this case, it was shifted 4 right and stretched by a factor of 2. All right, continuing from here, we have number 9, which adds some more elements. We have negative 2, absolute value x minus 4, all plus 4. So I'm going to insert a negative, and we're going to keep that minus 4, but add a plus 4 to the end. I could graph it again to see what it should look like. Then I can pull up my table and find the vertex. So this time the vertex is at 4, 4, and I can build around there. So 4 and 4 is here. Then from there we have 5 and 2, and 3 and 2. From there we have 6 and 0, and 2 and 0. So we see a negative slope of 2 in both directions. So we can keep building that instead of using the table. And our graph looks like this. Notice how this is kind of like vertex form. These 2 points here tell us the vertex of 4, 4. So we know that this was shifted right 4 and up 4 and stretched by a factor of negative 2. Oh, stretched by a factor, stretched by a factor of 2 and reflected over the x-axis. Yes, I'm sure you're laughing at me now because of my little slip up there, but you see what I meant there? So this one was shifted right and up 4, both ways, and stretched by a factor of 2 and reflected over the x-axis. All of those things. So we could fix our wording here. This could be right 4, up 4, stretched by a factor of 2, and reflected over the x-axis. All right, so continuing. Number 11, we have 1/2 of the absolute value of x, all minus 5. So we can clear what's in here. We put in 1/2, then parentheses, absolute value, which is math, number, choice 1. And I'm going to put the x there. I'm going to close the parentheses in this case because I want to subtract that 5. Now, if your calculator did the fraction form for you, then you wouldn't have to put that absolute value in parentheses. But because mine did not make the 1/2 look like a fraction, I put it in parentheses for just to be sure that it does show up that way. I can graph it to see what it looks like, and I can pull up my table. Looking for the vertex, seems like it's at 0 and negative 5, which makes sense because that would be our vertex since it says that it's minus 5 here, and there's nothing inside of the absolute value. So we can build from there. 0, negative 5 would be right here. Then we have negative 1 and 4.5. I'm going to skip that. Negative 2 and 4, negative 4 rather, and positive 2 and negative 4 at the same time. This one's the negative 2. That one's the positive 2, obviously. And then we have negative 4 and positive 3, or negative 3, and also positive 4 and negative 3. So you should see a slope of 1/2 there, so you could build it up. Then draw your lines, arrows on both ends. And now we can talk about what happened. So this was shifted down 5 and compressed by a factor of 1/2. Done. All right, so hopefully this is all making sense because it is very similar to when we did quadratic functions and their transformations. So you're going to complete the even graphs and descriptions at the end of this lesson on your own.